Yes. You've done probability since math 1.
I hate this.
All we're doing is building on it. Okay, so this should all be something that you have already done. Okay, remember when they made you make those tree diagrams and all that happy stuff? That's what this is. Okay, so 15.1, random experiments and sample space. A random experiment is any activity whose outcome cannot be predicted. Okay, I can't predict what's going to happen.
In Zeph's future.
Zeph's future is a random experiment.
Is it really?
Okay, so examples of a random experiment. Tossing a die. I can't predict what it's going to fall on. Okay, rolling a pair of die. Drawing a card out of a deck of cards. Results of a game. Forecasting the weather. Flipping a coin. All of these are random experiments. So we have a sample space, which is your set of all possible outcomes of a random experiment. So, sample space. This is outcomes, or what happens. Outcomes. I don't know how else you want to describe it. Okay, what happens, outcomes, what it looks like.
The paper field.
Okay. What happens, the outcomes, what it looks like. That is your sample space. N represent the size of your sample space. So this is your number of outcomes. Oops. Spelled it. This is your number of outcomes. And we're going to do a bunch of examples on this. As always, never leave you hanging on all that. Don't forget, tomorrow is snow day. Wear your snow hats, scarves,
Can I come
gloves.
with a big jacket?
You have to show your face. A ski mask is not going to be allowed.
Yo, what if you got the kind that shows your nose like this?
Nah, they're not going to allow that. Nothing that covers your face is going to be
Well,
allowed.
listen. It only covers your forehead.
That is not going to be allowed. Nothing that covers your face.
Listen, shut up.
It's always the same thing every time. You cannot cover your face.
I mean, can this person beat me?
Just like Halloween, you could not cover your face.
I mean,
Miss
Is that covering your face?
my hand?
Okay. It's a glove. It's not covering your face.
I don't. It's part of my hand.
Okay. So let's talk about sample space. We toss a coin and observe whether it lands on heads or tails. If I flip a coin, what are my options? Heads or tails. So guess what? That's your sample space. I can land on heads or I can land on tails.
either one, baby.
Either one, baby. Okay? So my sample space size. How many outcomes did we just write?
2.
That's it. Okay? So sample space is what can happen, and your sample space size is how many options you have. Okay, example 2, I'm tossing a coin twice. So what can happen now?
Heads, tails, heads.
Heads, tails, tails, heads. What else am I missing?
Tails, head.
Tails, tails, or heads, heads.
So you got 4.
So I've got 4.
Or heads, tails.
Okay, remember when I said you used to draw tree diagrams? That's what this would be. So option 1, I could have a heads or a tails. Option 2, I could have a heads or a tails. So that's where you got heads, 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 tails, tails, heads, or tails, tails. Okay. That gives you all of your options. Okay. Example 3, a couple plans to have 3 children and considering whether they may have a boy or a girl. So let's draw a tree diagram because this gets a little, the more options we have, the bigger it gets. So the first child, I can have what?
Boy, girl, boy.
Boy or girl. Okay, my next option,
You want us to write this?
I can have a what?
Boy, boy.
A boy or girl?
A boy or a girl. Okay, so off of my boy, I can either have a boy or a girl, and off of my girl, I can either have a boy or a girl. Okay. Off of these ones, I'm going to have another child. So guess what? We got some more boys and girls. I can have a boy or a girl, boy or a girl, boy or a girl, boy or a girl.
Oh, that's a bit much.
So these are all of your options. You can have 3 boys, boy, boy, boy. You can have 2 boys and a girl. You can have boy, girl, boy. Boy, girl, girl. So on and so forth. So how many options do I have? Well, I've got 1, 2, 3, 4, 5, 6, 7, 8. My sample space size is 8. And your tree diagram will list them all out for you. Questions on how I got?
Where's the other genders?
Where's the other what? What other genders? Listen, no, we're going with original.
Oh, shit.
Well, I do not mind anybody and anything else. We're sticking with the originals.
The basics.
Okay,
What happened? I didn't know what happened.
just nothing, Zach. Nothing. Okay, rolling a pair of dice simultaneously and considering the total of 2 die. What's the smallest number I can get if I roll 2 die?
Whoa.
2.
Snake eyes.
Snake eyes. Can I get a 3?
Yes.
Yeah. What about a 4?
Yeah.
5,
Yeah.
6, 7, 8, 9. When do I stop? 12. Okay, the only option you don't have is a 1 or a 0. All the way up to 12. So I have a sample space size of what?
10. 11.
11.
11. My bad. It was an accident.
He said 10.
It
Because
is.
you can't roll a 1. You've got a pair of die. So the smallest you can roll is a 2. Example number 5. Sarah, Krista, and Arlen are running for class president and vice president. Okay? Sample space. So I can have Sarah and Krista. Sarah can be class president. Krista can be vice president. What else do I have?
Yes.
In Arlen.
Krista and Arlen.
Cheryl Fisher, Ollie Christian.
Sarah and Arlen. What else can I have?
You had Kara and
Christy and Arlen.
Krista and Sarah. Arlen and Sarah.
Arlen and Krista.
Arlen and Krista. Okay. Why can I have
They switch roles.
AK and KA?
Because they got class president, vice president.
Good.
switch.
This one means Kara is class, or Krista's class president. This one means she's vice president. Okay. So because there's 2 different rules, I can flip flop them. So my sample space size here is a what? 6.
You said 6. Oh.
Okay. 4 more examples with this section, and this section's done, and we're going to move on to 15.2. Super easy. Super easy. Because this should all be reviewed.
I know you're gonna
Okay.
change it
The
to
other
test.
two.
I know you're gonna change it to test.
Here we go with this. I need to reintroduce you to a deck of cards. How many of you at least play solitaire, blackjack, something? You've seen a deck of cards. Okay. If you have not, please, at some point in time, download solitaire onto your phone. Christopher, get off your phone or it's mine. Okay. Sometime, at some point, download some solitaire on your phone, introduce yourself to a deck of cards,
It's fun.
because this is going to be very, very hard if you do not know what a deck of cards looks like. So, okay, focus. Need your conversation need to stop. In a deck of cards, you have two colors. You've got a red color and a black color. Of those colors, reds, you have two different suits that are reds. They are hearts and diamonds. You have two different suits that are black, spades and clubs. Inside of each one of those, you have 13 values from ace to king. Ace is your one card, or sometimes ace is your high card, depending on what they tell you in the problem. And inside of those, we have 3 face cards, jack, queen, king. Ace is not a face card. It does not have a face on it. Okay. So, example 6. Pulling a red face card from a standard deck on a single draw. How many face cards do we have that are red? I have 6. I've got the jack of hearts, the jack of diamonds. Okay, because remember, jacks are a face card. And hearts and diamonds are red. I've got a queen of hearts and a queen of diamonds. I have a king of hearts and a king of diamonds. So my sample space size here is a 6.
Yeah, I don't know.
This is where everybody usually struggles with probability. They're fine until I throw in a deck of cards.
Let's play ball.
Actually, we could play blackjack and talk about the outcomes and stuff of blackjack.
I like blackjack.
Why don't we do that?
No, there is no gambling. I am not about to lose my job for gambling in the classroom.
Wait, you can.
Okay. Top sellers. 3 boys and 4 girls are doing a class fundraiser of magazines. Consider how the top 2 sellers could be the same gender. Okay. This is where it gets difficult. Are you ready? Okay. If I have 3 boys, you need to denote that I've got boy 1, boy 2, and boy 3. Okay. So let's just work out how we could do it with boys. I could pair up boy 1 and boy 2. Who else could I pair with boy 1?
Boy 3.
Boy 3. Okay. I can do boy 2 and boy 3. Would it make a difference if I flip-flopped it and did boy 3 and boy 2?
No.
No, they're just top sellers. They don't have a specific spot. Okay, so those are all of my options with boys. Okay, now we've got to do girls. I've got 4. Well, not B. So I have girl 1, girl 2, girl 3, and girl 4. My suggestion to you is when you start pairing them up, pair them up everybody with girl 1 first. So I can girl 1, girl 2, girl 1, girl 3, girl 1, and girl 4. Okay, now go to girl 2. I've already paired them with girl 1, so who else can I pair them with?
3 and 4.
3 and 4. Girl 3, girl 2, and girl 4. And then finally move on to girl 3, and they can only be paired with girl 4. How many total is that?
6 and 3, 9.
1, 2, 3, 4, 5, 6, 7, 8, 9. Multiple choice test. Consider a multiple choice test with answer options A, B, C, and D. Consider the possible answer keys that could be made up for a 3-question test. Oh man, this sucks. Okay, if we would do a tree for this, you're going to have a lot of options. We can do something like A. That could be your answer. You could have A, B, A, C, A, D. Then guess what? You got to switch it up. A, B, A, B, B,
ABC.
A, B, C.
E, F, G.
Do you know how long it would take us to write out this sample space?
A lot.
No, let's not. Because you will all drive me crazy. Sample space size. So for question number 1, how many options do I have for an answer? Just question number 1. How many options do I have to pick an answer? If you have a multiple choice test. 4. You've got A, B, C, or D. I've got 4. Question number 2. How many options do I have? I still have 4. Just because I use A here doesn't mean I can't use A here. And then finally, question number 3.
4.
4. 4 and 4 and 4
And 4.
equals
Oh, that's
48.
Oh.
64? I have 64 different ways, 64 different answer keys that I can make for this multiple choice test.
64, baby.
4 times 4 is 16 times 4 is 64.
Oh, yeah.
Okay.
Man.
This you should have learned. I'm actually teaching this in Math 2. This is called your counting principle. How many options times how many options times how many options. Okay, so let's take a look at this one. Let's try to do this with the counting rule. Use the sample space for right now. Let's talk about the counting rule. I have 5 candidates. And the top 3 finishers are chosen as president, vice president, and secretary. So I need to pick a president. How many options do I have for president right now? 5. I've got 5 candidates. Now I need a vice president. How many options do I have for vice president?
4.
Why? Once I pick a president, they cannot also be vice president. So now I've gone down. Now I need a secretary. 3. So 5 times 4 times 3. So you have 60 different options. So you need to determine whether you can reuse an answer or whether once you use it, you need to take it away and not use it again. Okay, that's going to be your job in this next section. Okay. Any questions on sample space 5? Okay. Section 15.2, counting problems. We're going to use all of that towards the end to do this section. So we're going to be able to answer questions today about how many ways you can shuffle a deck of cards. How many NC license plates are there that contain 3 letters and 4 numbers? How many phone numbers are in an area code? We can find the number of ways that something can happen, to perform an operation, or any ways that an event can occur. So we've got bakery that sells 4 different soups at lunch and 7 different salads. Consider the below cases and determine how many different lunches each person could order. Michael goes in and plans to order a soup or a salad. How many options does he have? You could order a soup or a salad. We've got 4 and 7. Yes, 11. Okay, so I've got soup or salad. How many options do we have for soup? 4. What does the word or mean in probability? Add. Or means to add every time. Salad, we've got 7 options, which gives us a total of 11. Yes, ma'am.
Well, you said
So, Jared goes in and plans to order a soup and a salad.
multiply.
So now we've got soup and salad. So again, soup is a 4, and means to multiply, times 28, or yeah, times 7 is 28. She messing me up, giving me the answer back there already. Okay, so if you want soup and, you've got 28 different options.
For example, too, if you only use numbers, numbers. We're talking about pin codes. If you only know what's going on.
No,
Yeah.
no, we can also use zero. Okay.
Oh, yeah, you
A pin code. Okay. So you've got a debit card. How many of you have a debit card right now?
I got 3.
You know you have a 4-digit pin code.
Yeah.
You have a 5-digit pin code? I was gonna say, I've never heard of a bank that has a 5-digit pin code, but heck. A pin code requires 4 characters to your debit. Consider the below cases and determine how many different pin codes are possible. What numbers can you use for your pin code? 0 through 9. Okay, you can use anything from 0 through 9. How many digits is that? 10 digits. Okay, 1 through 9 is 9. When you add on 0, you actually have 10 digits. So we're doing a pin code that uses only numbers. Can I reuse the number? Like, can I have something like 2, 2, 3, 4?
Yes.
Yes. Okay, so the first character, how many options do I have for a number? Okay, slow down. Think for a second. You just told me I have 10 options for my digits. 0 through 9. So the first number that I plug in, I have 10.
Oh.
Okay. The second number I plug in, how many options do I have? 10. Times 10 times 10. Okay. I can reuse that number over and over and over again. My pin could be 2222. Okay. You have 10,000 different options for a pin code.
10,000.
That's it.
Yeah.
You have 10,000 different options for your pin code.
I already know that.
But think about it. There's how many people in this world? How many pin codes are actually exactly the same as yours? There's a lot.
Well,
Okay.
there ain't none.
What
Is
are
that
the chances of
right?
different from us?
It better not
They
be.
have to get the-
I mean, it's going to take a while, but it's not impossible. 10,000 is not that much. It's not impossible. Okay. Pin codes that use only letters. Think about how many letters are in the alphabet. 26. Okay. So I've got 26 options. Is it saying that I can't reuse it? No. So my pin could be AAA. So 26 options. 26, 26, 26. 456,976. They get more unique if you throw in letters.
What if you had that much money?
I don't know if
We're
I
not
want
talking about money right
Answer
now.
won't be less than-
Okay. Part C. Pin code can use only all letters or all numbers. What am I adding?
10,000 plus.
Oh, dang.
Good. Okay. So I have all letters. My options for all letters is 456,976. Or plus all numbers. My options for all numbers was 10,000.
466,976.
Beautiful. Okay. You had all letters or all numbers. What's different between C and D? Pin codes can use any letters or numbers. Oh,
Still add.
it's
Hold on.
it's add, but it's not add.
It says any letters or numbers. It doesn't have any numbers. I don't know. Yes.
Also, you.
Your keyword here is all. Okay. So what's happening here? They're saying that my first digit of my code can be either a letter or a number.
Oh, so we do 20,
So how many options do I have for slot 1?
36.
36. This could be any letter of the alphabet, which is 26, plus any digit, which is 10. And times 36, times 36, times 36. Okay. This one over here says my code has to be all letters first. Okay.
million.
So you had a choice of A, B, C, D, or you had a choice of 1, 2, 3, 4. Okay.
1,679,610. 616.
616.
Where did I get
Okay.
that from?
So this one again is saying I can have a code of A, B, C, D, or I can have a code of 1, 2, 3, 4. This one's mixing it together. I can do A2, B6.
Oh, R2D2.
I could do R2D2. And the nerd comes out. My Calc 2 teacher would love you right now. Because that was exactly where his mind would have gone. Yes. Everybody good? I don't want to skip ahead. Okay, so here's what we just talked about. Your multiplication rule. You always multiply when you see the word and, you always add when you see the word or. Okay, simple as that. Moving on.
Moving on.
Multiplication number 1. Roger has packed 4 pairs of shoes, 6 pants, 7 shirts, and 3 jackets for a week's vacation to the mountains. How many different outfits could Roger wear if he plans every day to wear shoes, pants, a shirt, and a jacket? So, we're wearing shoes and, oh, let's not use that symbol because I'll confuse you with plus. And we're wearing pants, and we're wearing a shirt, and we're wearing a jacket. Going to see this lovely little display on every problem, but just to bring people back to where we are. Okay. I drew in this lovely little table so you have one for each thing that you're doing. So, how many options does Roger have for shoes?
Oh,
4. To multiply.
okay.
Pants.
4.
Huh?
It's 504.
6 and 7 and 3.
How'd you get that? Oh, I see. Never mind.
504 outfits. He's prepared for 504 different ways to dress. Considering everything matches, though. Like, I could pack 6 pairs of pants and 5 shirts and only have 5 different outfits because that's all that matches. Okay. Number 2. A local diner offers a 4-course meal of an appetizer, soup, entree, and dessert, in addition to a drink choice. Okay, so we're getting an appetizer and soup and entree and dessert and a drink. Okay, so I have how many appetizers?
5,
5.
3,
And
9, 6.
and
Oh, limb.
8,110.
8,910 different meals. This is why I hate going to restaurants. I'm the most indecisive person. And once I go to a restaurant and I find something I like, guess what? Every time I go back there, I order the same thing.
I would get up.
Okay? So, part B says, how many different meals include an appetizer or dessert? So, here we go. We're getting an appetizer or dessert. I'm still getting, so, and a soup, and an entree, and a drink.
So you multiply those plus the dessert and do it instantly.
Okay, so how many options do I have for appetizer or dessert? 11. Okay, so appetizer or dessert is 5 plus 6. Okay, anytime you add you're going to need to throw that into parentheses. So it adds it first before it starts multiplying. So appetizer or dessert, you're not getting both. Okay? And you're still getting soup. And you're still getting an entree. And you're still getting a drink. Okay, so that's going to change it up. For what? An entree? That's your main course.
Yeah.
That's a word for your main course. So how many options do we have if we're getting appetizer or dessert?
3,267.
267. The people that get usually everything don't eat it all, unless they're like super fat kids like me. And you can eat it all.
I think I got high metabolism.
Okay. Another way you could have done this. Okay. You could have done it with appetizer and multiplied everything together without dessert, and then done everything as a dessert, and then added the two.
That's nonsense.
Okay. So either way works. So we could have also done this. You could have done, I'm getting appetizer, soup, entree, drink, and gotten a total. Or I can get dessert, soup, entree, drink, and then took these two totals and added them together to get your grand total. And you still would have come out to 3,267. Because this would have come out to be 1,485, and this would have come out to be 1,782. Okay. So either way works. Does not matter to me. Questions? Bless you. We should be able to get through these last two examples, and then all I have for you is practice problems. So you've got some work on after we get back from lunch. We're about to go in about 10 minutes. Okay. Example number 3. How many ways can you flip a coin 3 times and have tails as your first flip, or a tail as your third flip? Okay, so I want tails as my first flip. I'm flipping it 3 times. So this has to be tails. This can be tails or heads. This can be tails or heads. It doesn't matter. How many options do I have for tails? I'm flipping a coin. 1. That's it. And the second one, I don't care if it's tails or heads. So I've got 2 options. Second one, I don't care if it's tails or heads, so I have 2 options. So this way I have 4 options. Okay? It says or a tail is your third flip. So I want something like tails or heads, and the last one I want is a tails. So what does that look like? 2 times 2 times 1. So I get 4. So 4 plus 4 gives me, I should have 8 total options, right?
Yeah.
What if I tell you your answer 6?
I wouldn't believe
Your answer 6. Figure out why.
There's a possibility that you got tails as your first and third.
Good. Okay. So you could have something like tails, tails, tails. Okay. That satisfies this one and this one. So we've duplicated it. What else satisfies both that we've duplicated? Tails, heads, tails. So we had to subtract off the 2 that we've duplicated to get the answer here. You have an overlap. Why does the sum rule not apply to this question? Or does mean add, though. This right here, your overcount stops this. Okay, you have options that satisfy both rules. So anytime you have options that satisfy both roles, you cannot use the sum rule. Last one. We have an NFL team that has enough room on their roster to sign 2 free agents and must make the choice from 3 quarterbacks, 4 linebackers, 5 wide receivers. How many different ways are there to pick 2 players if they must play different positions? So, for instance, I can pick a quarterback and a linebacker. What else can I do? Linebacker and what? And wide receiver. Okay, or linebacker and wide receiver. What else can I do? Wide receiver and quarterback. Okay, so let's talk about our options and numbers. What does quarterback and linebacker look like? 3 and linebacker, 4. 3 and 4. Or plus, what does linebacker and wide receiver look like? 4 and 5. Or wide receiver and quarterback, 5 and 3. So how many total options do we have here?
47.
47. I have 47 different ways that I can sign someone.
Right.